Now, section 7.1 dealt with proving identities, right? Using identities like, reciprocal identities and Pythagorean identities, things like that, to prove other identities. Okay. Now, in 7.2, we have some more formulas, namely the addition and subtraction formulas, which we can do pretty much two things with. We can either use them to evaluate expressions, or we can use them to prove identities. All right. So this video is really going to focus mainly on using them to evaluate expressions. All right. So, there's your formulas for the sine of a sum, the sine of a difference, the cosine of a sum, and the cosine of a difference. And really, those just have to be memorized. But now, the nice thing that you should notice from them is that the sine of a sum and the sine of a difference formula are identical, except for the plus and minus sign here. So when you have the sine of a sum, there's a plus sign in between. When you have the sine of a difference, there's a minus sign in between. And then the same thing applies with the cosine of a sum and the cosine of a difference formula. You have the same, skeleton, if you will, of the formula, but for the cosine of a sum, you have a minus sign in the middle, and for the cosine of a difference, you have a plus sign in the middle. Okay? So what it really comes down to is there's really only two formulas that you have to memorize, and then you really pretty much have to just remember, that with sine, the plus goes with the plus, and the minus goes with the minus, and then with the cosine, the plus goes with the minus, and the minus goes with the plus. Okay? So the first thing on here, which I'll actually do just to give you a calculator example here, first show graphically and numerically that the formula for sine of s plus t works using the sine of x plus pi over 4. Well, what that basically means is use the calculator to show that the sine of x plus pi over 4 is going to be the same as the right side of this formula up here. So what would the sine of x plus pi over 4 be? The sine of x plus pi over 4 would equal, and again, we're using this formula up here. So x is playing the role of s, and pi over 4 is playing the role of t. So the sine of x plus pi over 4 is going to be the sine of the first one, which is the sine of x, times the cosine of the second one, which is going to be the cosine of pi over 4, plus the cosine of the first one, which is the cosine of x, times the sine of the second one, which is going to be the sine of pi over 4. And this can be simplified a little bit because we know what the cosine of pi over 4 and what the sine of pi over 4 are. They're both radical 2 over 2. So this is really the sine of x times radical 2 over 2 plus the cosine of x times radical 2 over 2. So now that I've simplified the right side, I just pretty much want to verify graphically and numerically that the sine of x plus pi over 4 is the same as the sine of x times radical 2 over 2 plus the cosine of x times radical 2 over 2. And how do I verify that graphically? I use my calculator. Right? And I'm just going to make y1 be the left side of this equation. So the sine of x plus pi over 4. And then I'm going to make y2 be the right side of this equation, which is the sine of x times square root of 2 over 2 plus the cosine of x times radical radical 2 over 2. Now, to verify this numerically basically just means go to the table and make sure all of my values are the same. So if I just make my table I can see that y1 and y2, no matter what the value of x is, are always equal, right? They're always the same. So that's showing it numerically. And then if I want to show it graphically, what I would do is I would just graph it, and hopefully zoom trig will give me a decent window here. And there's my y1, which is the sine of x plus pi over 4, which is just sine graph shifted pi over 4 to the left. And now the fact that you don't see anything else is good, because that means that the second graph, y2, just immediately drew over the first graph. If you actually want to see something, what you can probably do is, for y2, make the line be thicker. And then we can see how there's y1, and now y2 should go right over it, right? You see it does. It's just thicker. So that's probably a little bit better way to show it graphically, because the one graph just draws right over the other one. So we pretty much showed graphically and numerically that that formula works. Okay, now this second part, this proving, that we can do in class. Right, now these two are the ones that I wanted to spend a decent amount of time on in this video. Find the exact value of the following: the cosine of 17 pi over 12 and the sine of negative 5 pi over 12. Okay. All right, so our goal here is going to be to write 17 pi over 12 as a sum or a difference. Now, since 17 pi over 12 is, positive and fairly big positive, I'm going to probably try to write this as a sum. So what I want to do is think of how I can break down 17 pi over 12. Well, I could do like pi over 12 and 16 pi over 12, but that's not going to help me because pi over 12 isn't one of our special angles, right, from the trig wheel. So what would work here is if I looked at 17 pi over 12 as if it was 8 pi over 12 plus 9 pi over 12, because 8 pi over 12 is really 2 pi over 3, and 9 pi over 12 is really 3 pi over 4. Now, 2 pi over 3 and 3 pi over 4 are angles that are on my trig wheel, which I'll know the sine and the cosine of. Okay, so what I'm going to do is I'm going to rewrite the cosine of 17 pi over 12 as the cosine of 2 pi over 3 plus 3 pi over 4. And now what I would do is I would go up and look at my formula for the cosine of a sum, which is right here. And now my value of s is 2 pi over 3, and my value of t is 3 pi over 4. So I take the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. So this thing is going to get rewritten as the cosine of 2 pi over 3 times the cosine of 3 pi over 4 minus the sine of 2 pi over 3 times the sine of 3 pi over 4. And now I just use my trig wheel, pretty much, right? And see what I can get. So the cosine of 2 pi over 3, that's in the second quadrant where cosine is going to be negative. So it's the opposite of the cosine of pi over 3, which is going to be 1/2. And the cosine of 3 pi over 4 is again going to be negative. And so it's the opposite of the cosine of pi over 4, which is radical 2 over 2. Minus the sine of 2 pi over 3. It's going to be positive because it's in the second quadrant, so it's going to be the same as the sine of pi over 3, which is going to be radical 3 over 2 times the sine of 3 pi over 4, which again is going to be positive, and it's in the second quadrant, so it's the same as the sine of pi over 4, which is radical 2 over 2. So what's going to happen now here is this is a negative times a negative, so it's going to become positive radical 2 over 4, and this is a negative times a positive, so it's going to be negative radical 6 over 4. And you can then combine this into a single fraction and write it as the radical 2 minus radical 6 over 4. And that would be my exact value, which previously we wouldn't have been able to get, right? We don't know what the cosine of 17 pi over 12 is just from our trig wheel, but when we break it down into the cosine of 2 pi over 3 plus the cosine of 3 pi over 4 and then use our formula, we can get the exact value. So you can see what these formulas do is they allow us to get exact values of additional angles that we previously didn't have. Okay, and I mean you can do a little check on this by then just saying, all right, well, the cosine of 17 pi over 12 is that, oops, I'm sorry, not 17/12. The cosine of 17 pi over 12 is this, and is that the same as the square root of 2 minus the square root of 6 divided by 4? Yep, and in both cases I get the negative 0.2588, so on. Alright, so that works. That's my exact value of the cosine of 17 pi over 12. Alright, and I would do a very similar thing now with the sine of negative 5 pi over 12. What I would do is I would say, alright, well, this is negative, so I'm going to probably try to write it as a difference. Alright, so how could I get negative 5 pi over 12 as the difference of two angles? Well, maybe I could say that negative 5 pi over 12 is the same as 3 pi over 12 minus 8 pi over 12, which is true, and 3 pi over 12 is pi over 4, and 8 pi over 12 is 2 pi over 3. So I can actually use the sine of a difference formula, and I can write this as the sine of pi over 4 minus 2 pi over 3. And then I would plug into my sine of a difference formula, which is going to tell me that this is the sine of pi over 4 times the cosine of 2 pi over 3 minus the sine of 2 pi over 3 times the cosine of pi over 4. I end up with negative radical 2 minus radical 6 over 4.